Okay, I'm just going to look at integration by substitution where there is an x left over. Okay, so let's just have a look at x root 2x minus 1 dx. Alright, so, and it's going to be letting u equal 2x minus 1. Alright, so first thing you do is you go du on dx, which is 2, du is 2 dx. So looking at this here, that means that needs to be 2 dx. So you put a 2 in there and take a half out the front. So that means you can get rid of the dx. You can get rid of the 2x minus 1 because it's just u. So we have this leftover x here. So in order to deal with that, you get the u, you take your substitution to u equals 2x minus 1, and you make x a subject. So it's u plus 1 is 2x, x is u plus 1 over 2. So let's just sub this stuff in. So we have a half, and we have u plus 1 over 2, and then this part here is root u, and then the 2 dx is just du. Okay, so this half and this, that half comes out, that makes a quarter. U plus 1 to the root u du. Okay, so it's 1/4. Root u is just u to the half, and when you times that by u, it's u to the 1.5 or 3 on 2. U to the half, then it's u to the half du. 1 on 4, u to the, now that's u to the 3 on 2 is u to the 1.5. When you add another 1, you get 2.5, which is 5 on 2. Divide by 5 on 2, plus u to the half, add 1 to it, you get 3 on 2, divided by 3 on 2, plus c. So this will flip the 5 on 2, so it'll be 1 on 4 times 2 on 5, and it's going to be u to the 5 on 2, but u was equal to, what was u equal to? 2x minus 1. So 2x minus 1, 5 on 2. I'll just make room with my arrow there. Okay, so then we go plus. Now we've got 3 on 2, that'll flip and give you 2 on 3. We've got this quarter here too, because that's outside the bigger brackets. So let me just fix it up a bit more. So that could be 2x, and then you've got your quarter, and here we had 2 on 3. Okay, and then that will be 2x minus 1 to the 3 on 2. So it's a quarter, so that's 2, so it's 1 on 6. When you simplify that, that will be 1 on 6. And this one here would be 2. It would be another 1 on 6. 1 on 6. Okay. All right. Another. Okay, so we're going to do just an integration with substitution, just with an extra x, but we're going to make it a definite integral. So you need to also change the endpoints. Let's say the integral from 0, and it's going to be x on x minus 1 to the 4 dx. So we're going to go 0 to 2. Okay. And what we're going to do is let u equal x minus 1. Okay, so we start off and we go du on dx is 1. That's what we have here. So du equals dx, so that's gone. X minus 1's gone, that's u. So now we just have the extra x there, so we can go x is u plus 1, so that you can get rid of that. So far we're going to go u plus 1 on u to the 4 du. So it's looking good. We've just got to do our endpoints now. So the first endpoint is x equals 0. So use this, u plus, sorry, the other one, u equals x minus 1, so it's 0 minus 1, which is minus 1. And start at minus 1. Then if you put in x equals 2, because that's the other endpoint, then you get u equals 2 minus 1, which is 1. So it goes from minus 1 to 1. u4 plus 1, and it's on u4 plus, that's u plus 1 on u4 du. Okay, so when you've got this situation, you split the denominator like this, and that puts it into more of a form that you can actually integrate. u1 on u4 is 1 on u3, so it's u3 to the minus 1, plus 1 on u4 is just u4 to the minus 1. So adding 1 to the indices, you get minus 2, because minus 3 plus 1 is minus 2, on minus 2, plus u to the minus 3 on minus 3, from minus 1 to 1. So this is minus 1 on 2u squared, minus 1 on 3u cubed. All that's left is to put the endpoints in. So it's minus 1 on 2 times 1 squared, minus 1 on 3 times 1 cubed, minus 1 on 2 times minus 1 squared. So you've got to make sure that's in brackets if you put in the negative substitution. 2 times minus 1 cubed. Okay, so just put that all into your calculator. Oh, that's 3 times that, and see what you get.